Hey there, fourth grade. It's Miss Bush, your science teacher. Check it out. I want to remind you about our weekly outline because you can look at this more than once in a week. It's not just for Monday. So here we are. It's Wednesday. And today on Wednesday, I just want to remind you about all of our work. So Monday's work was a discussion board, and you were expected to watch these overview videos and add a comment. Tuesday's work was to submit an assignment. So if you have that done, check, check, you're on track. Wednesday, that's today, your job is to submit an assignment, check, check. If you are Miss Kaki's class, you have a Google Meet today. If you are Miss Cordham's class, your Google Meet is on Thursday. If you are Miss Witt's class, you are invited to the Google Meet on Wednesday or Thursday because there's no school on Friday. And just a reminder, Thursday you have a quiz on Schoology and I think you'll really like it. It's not meant to be a scary quiz. I wanted to make our Thursday work friendly for you, so I think it's a friendly quiz. Okay, today for your Schoology work is titled, oh, the title's off. I better fix the title. 3.3 Static Phet. That is the Phet website. And everyone, I'm sorry. There is a Dementor in my house at the moment. I am sorry, fourth grade. We have an interruption of our static. The Dementor is attacking me. Dementor, go away. Expecto Patronus. All right, Dementor, let this teacher finish her work.
Roger.
Okay. Goodbye, Dementor. That was not planned, but here we go. Your work is planned. We are learning about static. The Dementor is not going away, fourth graders. He thinks this is funny to interrupt this grown-up who's trying to get their work done. I hope this Dementor doesn't attack me again. I do not want the Dementor's kiss. Oh, he's gone away for a moment. We can keep working. Here we go. We are learning about static today. And question 1, what did you learn about magnets from Gizmo? So go back to Gizmos. You can go back in anytime through Clever if you forgot. Clever, you log in with your Active Directory. That's your S number and your password. And then you get here and you get to explore. We had a lot of fun exploring magnets on Gizmos. And just like this Dementor is attracted to my interruptions, different magnets are attracted to each other. And so opposites were attracted. And if you remember, south and south of a magnet, opposites are the same repelled. So magnets can attract and repel. And if I add those magnetic field lines and tap the table to get those lined up, I really am working right now. Okay. If I do that, we can see these energy lines going all around the magnets, all around. And I really like that because that reminds me that this magnet has energy and power and it doesn't have to touch something for that power. It can go across distances. Well, I have a new website for you to check out today. And this new website is called Phet, and the links are going to be posted on Schoology so you can try it out yourself. For the Phet website, you can have a lot of fun exploring static. Let me reset everything here. Let me go to one balloon. This balloon has a positive and a negative charge. And eek, pause, what is a charge? So let's come over here. Here is an atom. Everything in the world is made up of these atoms, and atoms have these electrons that go in circles around the outside, and electrons have a negative charge. Inside of the atom, there's things called protons and neutrons. Protons and neutrons do not like to go to parties. Electrons like to party. So even though the electrons are part of this atom, sometimes this electron might go visit someone else for a little party. So, coming back over here. Here are the protons. Protons never go to parties. They just stay inside the atom. But these negative electrons, they like to have fun. But not all electrons like to have fun. The electrons on a wool sweater like to have fun. The electrons on my hair like to have fun. But not all electrons are party electrons. So check it out. This balloon is okay having extra electrons around. It's okay hosting the party. But the electrons on my hair like going to parties. So if I go rub, 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 The electrons from my hair are going to jump to the balloon. I'll show you exactly what I mean. If I go rub, 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 the electrons are now attached to the balloon. This balloon now has a negative charge. If it was a magnet, this would be the negative side. And the sweater now has a positive charge. If it was a magnet, it would be the plus side. And just like opposites attract, the balloon and the sweater get attracted to each other because of the charges. Now, if you remember, same things repel. This balloon has a negative charge and the wall is neutral. I can go make that repel even bigger by getting all of the negative charges, and there we go. I'm pushing away the negative electrons. I can reset and get a second balloon, and I can get a few negative charges here. This one wants a few negative charges. Now watch how these balloons play with each other. I want more space for my balloons to play, so I'm going to remove the wall. I don't know if I can remove the wall right now. Let's see. I can't remove the wall because of my video editing software, but these balloons have charges. That's what static is. Static is when a few electrons go to a party. So they leave the hair and go to a party, those silly party electrons, and now there's extra negative charges on the balloon. And energy doesn't like that. Energy wants to be balanced. So if I look at that picture one more time, those electrons are what's going to the party. Well, here's one more way to look at static and electrons. Here's John Travolta. He's known for some movies in the 70s and 80s and 90s, but mostly the 70s. And John Travolta is getting some static. Except here he's John Travoltage, not John Travolta. As he gets his static built up, eventually it has to discharge somewhere or go back to being neutral and balanced. Nature does not like being unbalanced. So right now nature's like, okay, we have a lot of party electrons inside John Travolta. But once his finger gets close to this doorknob, which is a conductor, and lets energy move, we get back to a balance. Your work today is right here. Number one, what did you learn about magnets from gizmos? Well, we learned that opposites attract, same sides repel, and the energy goes bigger than just the magnet itself. Explore the Phet website. What did you learn about static from Phet? I hope you just saw all about those electrons that like to go in a party, and the electrons from the sweater went to the balloon, giving the balloon a negative charge. Add a screenshot from the Phet website and explain the science idea. So this is what I don't want. I know you're going to do it. Someone always does it every year. I do not just want screenshots of John Travolta picking his nose, okay? I know you fourth graders, yeah. If you were to do that, you would also need a lot of negative charges, and you could take a screenshot of this explaining what's going on in the picture. But if you just send me a picture of John Travolta picking his nose, no. It doesn't count for your work. Oh, but I know someone will try. No, you're not getting points. So add a screenshot from Phet and explain the science idea. And then right here, question 4, what is the same about magnets and static? That's been our big question all week. What is the same about magnets and static? And we just looked at John Travoltage. We just looked at what an atom is and what these party electrons are. And we looked at how those party electrons move here on this website. And we looked at this and how magnets move. So what's the same about static and magnets? I'm really excited to see your work. Even if your work's not perfect, even if you don't have every idea on there, just turn in some work, please, fourth graders. I love seeing your learning.